Good afternoon. Am I audible?
So voice is breaking.
Now, hello, am I audible?
Yes, sir. Yes, sir. Now audible.
Okay, thank you. My screen is visible.
Yes, sir.
Yes.
Okay. So let's begin with the course VLSI Physical Design. Good afternoon to one and all present here. So in the last three class, we discussed fundamentals of digital circuits, why we need to design the digital circuits, why what level of complexity is involved with the digital designs. And today onwards, we are going to start with the physical design of digital circuits. Can anyone identify this square box? What it is?
So it's a design flow.
No. So I tell you, whenever you enter in the any VLSI companies, these are the departments or stages available that you have a choice. You can go for process design kits, or you can go for the post silicon. You can go for system on chip, analog IP, library generators, digital IPs, how to use different methodology, that kind of department, or you can go for packaging. So in any industry, VLSI industry, this research or development groups are available. You have to pick up any one box and you have to master in that box. Maybe libraries, maybe PDK, whatever you write. But to pick up any one box, you have to pass through these 2 semesters, and then at the end of second semester, you have to say, yes, I am good in this, maybe SOC, maybe in analog, maybe in PDK, maybe digital IP, like that. Okay. So these are the working domains available in the industry, VLSI industry, where huge demands of VLSI engineer in this area of interest. So let's begin with our 3:11:21 course code, VLSI physical design. So let me give you a few important things that is required throughout the semester. I am following these 3 titles, which is considered as a textbook, or we can call as a reference books. First is Sadiq M. Said or Hasib Yusuf, VLSI physical design automation, theory and practice, from the word scientific. So all the course contents available in this first title. Second is Andrew Kang, which is VLSI physical design from graph partitioning to timing closure. Very important book. It is from Springer. And third one is only for example. There is a practice problems available in VLSI physical design automation by Sound Q Lim. So I am following these 3 titles throughout the semester for both theory content as well as examples, numericals. Actually, if you see the past year question paper, or if you have some knowledge, this course has only the examples. So we are asking the numericals based on the theory content, not just like derive this, derive that. Say post graduation level design problems we are going to ask definitely in this course also. So more and more practice we are going to do in this course, and to solve the different physical design issues. So you can take the screenshot of these 3 titles also, no problem. And you have to, this all 3 books are available in ebook also. Just use the sciencehub.com, enter the DOI of the book. You can freely download this all 3 titles. Or in future, if you are not able to download, just mail me. I will give the link from where you can download this. At the end of this course, we are going to learn these 3 major points. One is the fundamental of graph theory. We'll discuss this all point in upcoming titles. Various steps to use to design the layout, like floor planning, placement, routing, etc., by using different types of algorithms. It is not like just one algorithm for one steps. We have a n number of algorithms we are going to use, and we have to use in our software that algorithm which gives the optimum result. And also in the lab session, we are going to use some CAD tool, computer aided design tools, for the VLSI physical design to implement different algorithms. So these are the 3 learning outcomes. At the end of the course, you will be able to learn these 3 major concepts. Syllabus is there, 45 lectures we plan with 6 unit. First unit generally deal with the basic graph theory, how the graphs are useful for designing the logic diagrams, to solve the logic diagrams, like that. Different basic terms we are going to discuss related with the graph theory. Then after second chapter onwards, we have all the steps available to design the physical design of the circuits. Chapter number 2, chapter number 3, chapter number 4. And chapter number 5 is for the verification of our layout, which is a clock tree networks, clock tree synthesis. Chapter number 6 also related with the timing analysis, static timing analysis, sign off, that all for the final layouts we are going to check the DRC, LVS, parasitic extractions like that. So entire syllabus divided into 45 lectures, starting with some basic concept and finally to verification of our layout. Teaching scheme is also here. Almost for all the courses of first semester, we are looking this 3 seat 1121, 2 hours lab session. Total credit is 4 for this course. Continuous evaluation, that includes the class test as well as sessional examination. LPW also there, which is a weightage of 20%, and finally semester end examination 40%. So in between you have also the special assignment that you have to complete before the semester end examination. So 3 components are planned in the continuous evaluation. One is the quiz or class test, second is the sessional exam, and third one is the special assignment. That overall weightage you have to give for the 40%. Whatever work we do, that is 20% for LPW, and SW is again 40%. Let me start with some basic concept. So let's begin with our basic concept what we have seen in the last few lectures. We are looking the final layout. We are looking the final layout of the circuit, and that circuit is our digital circuits. In one line, can anyone tell me why digital circuits? Very quick. Yes, anyone?
Very easy to design the digital circuit.
Why we select digital circuit?
Very easy to design.
Easy to design. Okay. What else?
So this simulation is possible.
Simulation, of course, nowadays possible for everything. Let me write here also, no problem. Simulation is possible. What else?
So
Noise.
Noise performance is better.
easy debugging.
Debugging is easy. Okay. What else?
Easy to recreate.
Easy to duplication is possible. If you want to go for memory, just you have to repeat the box. What else? This digital are playing with that binaries or maybe 1010, that kind of coding. So instead of using that Greek word or some alphanumeric codes, computation with binary code is very easy. That's why computational complexity handled by binary numbers is very high. So you can design good performance or better performance circuit with higher computational complexity. The reason that we have a use of simple binary numbers. It's not we are using for analog 1010. So computational complexity handling capacity of this binary number is large. You can do the computational multiplication, addition, whatever, great extent. So that improves the performance of your design. So everything we are looking for the digital circuits, and as I said in the last few lecture also, we are not going to design any small half adder, full adder, comparator like that small. But in real time, whenever you open the cell phone or any digital system or any digital ICs, you can see that so many number of components are available, and with the small area as well as higher speed. At the same time, we need to achieve the low power dissipations. So computational complexity is required very large in order to achieve the better performance. So everything we are looking for the digital circuits. And if the circuit is very complex, manual approach you cannot use to design the layout. Manual approach you cannot use to design the layout. If I have a 100 or if you have 5 to 6 components, it is easy to design the layout. But if there millions of transistors are there, manual approach is never and never used. For that purpose, we have to take the help of software. So entire industry available electronics design automation. Nowadays, cost of the software is large as compared to hardware. So this is the reason that too much complexity you have to add in your design algorithms in such a way that complexity is handled by your software. So everything we are going to use for this layout generation, we are going to use software, or as a theory we call as a different types of algorithms for that designing the software. So all the course contents are also designed in such a way that you can pass your digital circuits into this all the steps, and finally you get some useful layout. Useful because that layout can be fabricated by the foundry people. This layout not just we are going to design for our fun. Definitely this layout is easy to fabricated by foundry people. So there are so many checks we need to perform before giving to the foundry. So let us discuss what are the steps we have to pass to generate the final layout. Okay, so this in the next 40 minutes, 45 minutes, what I'm going to discuss is nothing but related with the actual physical design that we are going to see in detail for remaining 44 lectures. So let's say we have a very complex circuit in that we have 10 raised to 10 number of gates are there. Can anyone tell me how many number of transistors are there if there is a 10 raised to 10 number of gates available? If it is a CMOS implementation. You can speak, no problem. Right, wrong, no.
So 2 into 10 raised to 10.
So one answer is 2 into 10 raised to 10. Yes, any other number?
So 4 into 10 is to 10.
So depends which type of gates are being used.
Yes, which types of gates and how many inputs are there? Then you can decide how many number of transistors you require. Suppose we have only single NOT gate. If we have CMOS implementation, we require 2 transistors. Okay, single input, single output, but we require 2 transistors, twice n, where n is number of inputs. So in reality, if I'm giving the transistor level design like this CMOS or any other, okay, and if I'm trying to design the layout, which one is easy? Gate level is easy or transistor level is easy?
The gate level.
Yeah, of course, gate level. Okay, because later on definitely I have to convert that gate into transistor, and then finally I have to put the actual size of the transistor. But to generate the abstract layout or abstract kind of things, definitely I have to start with the digital gates. Okay, so whatever inputs we are looking to this software or this physical design, this is our definition of physical designs. VLSI physical design. Someone asked, define the VLSI physical design. What you have to say? It is a process to convert this circuit into the layout. So now this circuit is our digital circuits, and in the industry this word is identified as a circuit netlist. Netlist is nothing but how many number of gates are there, what is the interconnection between these two gates or three gates, like that, so that all the information is available in that netlist. And that netlist is our gate level netlist if we are using the gates to convert into the layout. The process to convert circuit level netlist into the useful layout, that process is called the VLSI physical design. So step number 1 in this physical design. So let me give you the one analogy. If you have a big city, and let's say it is a 1,000 square foot by 1,000 square foot, just I am taking rough numbers, and if you want to accommodate so many houses, okay, if you want to provide some, if you want to design some city or some specific area for resident purpose with so many number of houses, so single house, if you do the planning for single house for all the residents, it is very difficult to manage everything. Okay. So similar case here, if you have very complex circuit in form of the gates, digital gates, okay, it is very difficult to generate the layout of this complex digital circuits. Okay. You require so many interfaces, you require so many interconnection in such a that you have to accommodate everything, all the connection between the gates. You have to do the wiring of all the gates in such a that communication is possible. So if this is the case, step number 1 is very useful. At the time, we have to divide entire complex circuits into the small blocks. Similar way, if this is the entire residential area, it's only not a single residential house is there or single flat is there. That flat is divided into number of blocks. Definitely, if you recall any buildings, residential buildings, block A, block B, even you can say the apartment also, 5 apartments in this society, 3 apartments, 3 blocks in society, maybe ABCD, like that. So it is convenient for everyone and all the communications interfaces is possible. Easy access for each and every houses is also possible. Can anyone tell me the name of that step number 1? Yes. Can anyone identify?
Specification.
No. Specification and everything is come here.
Floor
Circuit
planning.
partitioning, floor planning.
Huh?
Floor
Circuit
planning.
partitioning.
Floor planning.
Partitioning is good word. Dividing, you can say. Divide or partitioning. Partitioning is good word or appropriate word for the physical design. We have to do the partition of our complex or millions of the gate into small modules, small block. Okay, so if there are, let's say, 10 raised to 10 number of gates are there, you can use balanced partition or unbalanced partition. Can anyone tell me what word balanced partitions means what?
Sir, dividing the total space into equal parts.
Yes, in this box I have a 5 flats. In this area I have 5 blades, and if I do the addition of all this is my, it gives me the total. So that is called balanced partition. Or if I have a size constraint, I can do the unbalanced partitioning also. Okay, so depends on the requirements. I can do the partition, maybe balanced partitioning or unbalanced partitioning. But the concept is that you have to first pass through your design with this partitioning steps. If you do the partitioning, definitely you have to work for only that small sub block or modules. Of course, you have to work for each and every, but not at very high complexity, like this 10 raised to 10. Okay, is it clear? This step partitioning. We'll take example also, no need to worry. This is the definition only. So if you have a very complex circuits where number of gates are very large, directly we are not going to start the layout. We first pass through this layout into the partitioning. Remember, this all I am discussing in this box. This box. Before this box, you have already that specification. Someone says that, but it is already decided at the initial state. Then we have logic design, logic synthesis, everything. Logic design, logics, and here we are generating some netlist. This netlist we are applying into the physical design software. And that give me the layout. Okay. So at present I am discussing this part only. Our entire course is available for this box VLSI physical design to convert circuit level netlist into the layout. So first step in my design in the process is the partitioning. Very complex circuit, you can do the partition, you will get some small module. What other information I will get after partitioning? Can anyone tell me?
Between different modules.
Yes, interface, we call as an interface. So not only this, how many gates available in this box, but also how this box are interconnect with each other. That information is also available, which is my output of partitioning. So two informations are available, which is the output of partitioning, number of modules, and second is how they are interconnected, how interface is available between this module. Let us take one small circuit. I'm going to sketch small circuit. For textbook and exam, it's not like that we have to take 10 raised to 10 number of transistor. Otherwise, your entire year just pass to solve one steps, one algorithms to solve that numerical. You take small circuits like this to understand all the steps of physical design. Let me put one more. 1, 2, 3, 4, 5, 6, 7, 8. Let me give the number also. Now, question for you. This is the circuit. This is not a circuit for 10 raised to 10 number of transistors like this. But still we can, if this circuit has 8 gates, 1, 2, 3, 4, 5, 6, 7 and 8. There are total 8 number of gates are available. And if you want to understand the partitioning, Okay, if you do the partitionings, what advantages we'll get, that we try to understand with this small circuit. Okay, so question for you, can you give me the two blocks, box 1 and box 2? I call as a block also or module also, no problem. Block A and block B. Which gate number you place in block A and which gate number you place in block B? Take 2 minutes and give me the answer. My question is clear. Can anyone respond?
Yes, sir.
Okay, Subham. My question is, yes,
Uh,
Subham.
in block A, 1, 2, 3, and 4 gate will come, and in block B,
Yes,
5,
yes.
6, 7, 8.
Okay, I take your answer. 1, 2, 3, and 4. Subham, you're given the answer? 5, 6.
Yes, sir.
Okay, thank you. 5, 6,
And
7,
so,
and 8.
there is also one possibility like
Yes,
1,
yes.
5,
No, no.
7, 8,
Let me put second possibility. 1,
5, 7, 8,
7, 8.
2, 3, 4, 6.
Yeah, 2, 3, 4, 6. Remaining student also try. 2, 3, 4, 6. Okay.
Sir, we can take 1, 2, 5, 7, 8 in the block A.
Let me sketch because I need to clear something. Now you can speak. Speak.
Sir, we can take 1, 2, 5, 7, 8 in block A,
Oh, and this one
and 3, 4, 6, 7, 8 in the block B.
3, 4, 6.
7, 8 in block B.
How you can take
Or
7, 8?
yes. So we can take 1, 2, 5 in the block A and 3, 4, 6 in the block B.
So what about 7, 8 also here?
Hmm.
The partition equally.
You, at present, let's say I put the condition equal partitioning, equal number of gates in
Yes.
both block A and B.
Okay.
Any other balance partition? Okay. Any other answer? Can anyone try? Actually, there are so many possibilities. Okay. You can put 1, 2, 3. You can, but only the numbers in, if you see, you can put 1, 5, 6, 7, 8, 4 here and remaining 4 here, and you can see 16 possibilities are there where you can do the partitioning. But if you see this two one, which one is better?
The first one.
First one.
First one. Okay. Someone says that, I forget to see the name. Someone says the first one. Why?
Sir, we can take one input and output of A is directly connected to block B.
Okay. Someone agree with second answer, or all
Me,
6, 18 students with first answer?
sir, I will go for the second option.
Yes. Can you
Uh,
justify? Good.
Sir, because if we select the first option, then we have to take 8 inputs in the block A, and in block B, we have to also take another. Then in block B, we have to take 4 inputs because another ones will be the interconnected. But in the second option, if we consider, then and if we partition, then we have to take four inputs for each block.
4 inputs for each block.
Yes, sir,
Okay.
because 1, 2, 5, 7, 8. So 1 and 2, there will be 2 inputs, and for 3 and 4, we are having another 4 inputs.
Okay, let me, any other answer? Because we all take part and then we'll go ahead.
Yes, sir. Second
Sir,
option
but
is better, I guess.
Hardi, what you want to say? First one or second one?
Second one.
Second one is more better.
Delay wise, it is equally divided, I think.
Delay, which delay? Because
Propagation delay of all the gates.
because same number of gates in both, so gate delay is not major issue. 157, 4 यहाँ पे भी है, 4 यहाँ पे भी है.
sir, I don't understand in block A of second option which have a 4 input.
Yes, Pujan, you are saying something?
Sir, Shubham told na that in block A second option there is a 4 input, but how?
In second case, there are 4 inputs. No, not at 4 inputs. Let me give the some hint. Let me I put one line here, dotted line. This is my block A. This is my block B. Now you tell me between block A and block B how many wires you require.
Sir, 4.
Of course, 4 wire. 1, 2, 3, and 4. So if I include 1, 2, 3, 4, this answer 1, 2, 3, 4 in block A, 5, 6, 7, 8 in block B. I need 4 wires to do the connection. To complete the connection, I need 4 wires. This 4 wires. 1, 2, 3, 4. Now think for second answer.
That's what I told, that number of wires for the second partition would be equally divided as compared to first option.
Now 1, 5, 7, 8 in one side. 1, 5, 7, 8 at one side. 2, 3, 4, 6 at other side. Quickly, anyone tell me how many number of wires we require?
Are equally divided as
Well,
the
you give me just number like 4 here I given. 4 है, 5 है, 6 है, 2 है, 3 है, 1 है, क्या है? How many number of wires?
sir, total for A block there would be a four wires, and for B block there will be
No, this
4 wires.
wire is not separate for block. Between wire is always between equal. So let me put, yeah, exactly. Karan given the answer 2 wires. So let me put that partitioning also like this. क्या number है वो? 1, 5, 7, 8. So I have to cut the line like this. ये भी
I
यहाँ से
would
निकाल,
think
ये भी यहाँ से निकाल के मैं यहाँ डाल दूंगा. Doesn't matter. A यहाँ पे है, B यहाँ पे है, A में है 1, 5, 7, 8. Yes, 1, 5, 7, 8. 2, 3, 4, 6. 2, 3. Yes, correct. So now you tell me how many wires you require? 2.
So 2
So now you tell me which partition is better.
second one.
Why?
Interconnection is less.
Yes, if your 10 is to 10 millions of transistor or gates are there, if the definitely long length of wire is required, but if you perform the partitioning like this, where
Complexity will be reduced.
of course complexity is there, but interconnection between two blocks, two modules is reduced. If interconnection is reduced, definitely parasitics involved with that interconnection is also reduced, and we get some high speed, less delay. Do you agree with this sentence?
Yes, sir.
So you have to
Yes, sir.
perform the partition not just for the fun, or not just like that 4 यहाँ पे रख दिया 4 यहाँ पे रख दिया, or still number of wires between two blocks is higher. You have to use proper way. This is at present we are not discussing any algorithm or nothing, any step-by-step process of partitioning. Just to understand what partitioning give, or what is the expectation from the partitioning block, partitioning steps. So you have to perform the partition in such a way that you get this kind of result where interconnection between block is reduced. If interconnection between block remains same, what advantages we get in terms of delay? No, delay remain as it is. But so this partition is not preferable. So if interconnections are reduced, definitely we get some advantage, some improvement in our delay performance. All of you with me?
Sir,
Yes.
sir, is this the best solution you told na that 16 solution there? So
You have to try and see. Is this possible that if you 4 on this side and 4 on this side, you can reduce even less than 2? Now you tell me, if you want, if you require only one interconnection, what you have to do between one A block and B block? Can anyone quickly reply? ये रेड लाइन को मैं यहाँ से भी निकाल देता हूँ जो मैंने पहले से निकाला था.
The last gate we have to make separate, and others we have to make separate. Then it would be only one connection there.
Yeah, absolutely correct. Let me resketch this part, black color. So Subhan said that if I am require only one connection between box A and box B, this is my A block, this is my B. So it is in which category? It is in unbalanced category. But what is the advantages? Only one
Yes.
only one wire delay I have to consider, or I have to worry about only one wire delay instead of 2 or 4 in previous balance partitioning. Okay. So we have algorithms available that gives equal numbers in each blocks, like 1, 2, 3, 4, 5, 6, 7, 8, or like something this also 1, 2, 3, 4, 5, 6, 7 in one box and only 8 in other. That is unbalanced partitioning. So partitioning with balanced algorithm also is possible. With unbalanced algorithms are also possible for the partitioning. Is it clear this step?
Yes, sir. Yes, sir.
Let me try give you another example. The rest of the students also participate in this discussion. Let me sketch one more logic. Actually, I am not good in digital gates. I am interested in something else. Let me give you small circuits. Some XOR gate is there, some mixed gate is there. ये जो लॉजिक है डायग्राम इसको आपको पार्टीशन करना है. लेट मी गिव यू द नंबर सो इट इज मोर क्लियर. 1 here, 2 here, 3 here, 4 here, 5 and 6. चलो, take 5 minutes and give me the correct answer. Optimum answer चाहिए. Correct as well as optimum.
The balance partition?
Yes, take balanced partition. Otherwise, if I am saying unbalanced partition, all 18 give the answer in 0 time. We have no time limit. You can take your time. More than 45 lectures even we go, no problem. I hope number is visible. 1 2 3 बीच में 4 है, left side 5 6.
So 564 is in one block A, and the 123 is in block B.
5 4 6 at one side, yes, and 1 2 3 is on other side. Okay, so how many interconnection between block A
Two.
and block B?
One.
One.
Single inter.
Single one. So this is my output. Let me put the line here, red line. I call it the red line. Okay, this is my A, this is my B. So it's not like that whenever we start actual algorithm, immediately your answer will not come. Maybe you have to perform 2 or 3 or 4 5 iteration, and after 5 to 6 iterations you will then say that yes, 1 2 3 on this side and 4 5 6 on other side. Maybe after one iteration your answer is not optimum. Let's say your answer is 4 2 3 sorry 2 3 4 and 1 5 6. Let me sketch that line also. I hope you are with me. You are understanding this one. Let me put the blue color. Suppose you perform the iteration number 1 and you are getting this answer. So how many connection? 1 2 3 and 4. Oh sorry, I have to put this also inside this. Sorry, this gate also inside the box because balance partition. So 2 3 and 4 for one box or one block, and for remaining it is 1 5 and 6. Let's say it is my iteration number 1. So it's not optimized. There are some checkpoints are there, and for that you can say that iteration is not sufficient. You have to go for iteration 2 iteration 3 like that, and once you check points for all these iterations, you can say iteration 5 gives the good result like this 1 2 3 and 4 5 6, only one interconnection. So in that case you have to repeat the algorithm multiple times. It's not like that. If circuit is 2, अभी तो यहाँ पे 6 गेट ही है. Suppose 10 raised to 10 gates is available. It's not give answer by one iteration. You have to perform so many number of iterations, 100, 200, and finally it gives the optimum results. All of you with me?
Yes, sir.
Yes, sir.
Good.
Yes.
So now we can imagine that complexity involved in computation of this all is possible only because of software. If you do by manual way, yes, you can do by manual way without any algorithm if circuit is too small. ये 6-7 gate here, then you can design or you can do the partitioning. But if it is huge number of gates, millions of gates, manual approach never and never work. Definitely you have to take the help of software. You have to write down some code, okay, and then you can use that code for complex circuit also. So partitioning expectations, this is the first step that we are doing for getting the smaller interconnection, that is the expectation from partition, and we get different modules as well as interface information. So this I am looking is the partitioning output. Step number 1. What is the input to the partition? Can anyone tell me what input we have to apply to the partition?
Netlist.
Yes, netlist, gate level netlist that act as the input. यहाँ पे जो है वो gate level netlist, it means ये जो diagram है वो सब. In the diagram we have this input, this connection, this, that is called netlist. In this chapter, this is not actual starting of the chapter. Later on we have some terminology also. If I am giving this circuit, write down the netlist manually. That is also possible. We'll see also later on. So this netlist act as the input to the partitioning, and output of partitioning we get different sub modules as well as interconnection information. So if you do the optimum partitioning, your speed, some benefit you will get in terms of speed. Okay, so that is first step of VLSI physical design. We have entire chapter number 2 in our syllabus that is totally related with the partitioning algorithm, balanced partitioning, unbalanced partitioning. Is it okay? Step number 1, all of you?
Yes, sir.
Yes, sir.
Okay, let us move ahead. Now, as I given the analogy, we have a large residential place. Okay, so this residential place is nothing but in VLSI we call as a area, die area. You have to utilize this into this die area where you have to accommodate everything. Okay, you have to accommodate everything in this given die area. It is not like that पहले आप सब buildings बना दो, then you decide this is the area. Area is given initially, your die size, your IC size, you can say. This is the length of IC, this is the height of IC. That is fixed based on the design constraint. You cannot cross that W at that length and height. So second step is that which is called the floor planning. So analogy says that only in this area you have to accommodate all the residential flats. So something like this area is given for, let's say, Bhopal in Ahmedabad, famous area. Let's say this area is given as a CG Road, again very famous resident area in the Ahmedabad. Let's say this is given Kalupur railway station, maybe you know or will come to know once we are here. Likewise, this all this. Okay. So this box, okay, you have to plan, you have to well plan this box rectangle, which is called the floor plan. In that you have to accommodate your flats, you have to accommodate your design in VLSI. So once you do the floor plan, your output of the floor plan is like this. Can you tell me what is the input of the floor plan?
Module.
Module as well as interconnection between modules. So what I have to do one by one, let's say this is A, B, C, D, and some interconnection is also there in between this. So one by one, I have to pick up that module over here and I have to place. Let's say C is available over here like this. It's not randomly. If you do randomly, what is the disadvantages if you do randomly?
It will be difficult.
Area becomes higher. So you have to utilize the very effectively area in such a that this, let's say this is your B is there, somewhere over here your D is there, some E block is there, let's say this is my F. So this kind of output which is available with the floor plan. जब आप कोई फ्लैट बनाओगे, you can decide that this is my kitchen area, this is my drawing hall area, like that. Okay, so similar way over here, in entire given width and height in this die area, you have to place this box very effective way. So area performance we are going to check with the floor plan. More we'll discuss, of course. So whenever we have anyone seen the layout of any IC or any design? What layout is called? Layout is nothing but rectangle or blocks like this. Have you seen layout? Maybe square, rectangle, block. Is there nothing but the layout? Of course, we'll see layout also in this course. But final output of layout is nothing but combination of different size of the rectangle. Maybe I'll say this rectangle, this square, maybe this one. So this is nothing but these are all your designs. So floor planning is the area estimations where tentative area, you can say yes, tentative area of your flat or your home is like this, where kitchen is available here, drawing hall is available over here, TV showcase, floor is available over here, like that. Staircase is here, some approximate you can decide. So today we discuss 2 steps, and upcoming lecture also we are going to complete the all steps, then we see some terminology, graph theory, everything. Any doubt in these 2 steps you can ask. Hello.
No doubt.
Partitioning and floor plan. Floor plan we are not seeing in too much with example because of our time. Definitely we continue floor plan with more example, so clear to you. But this is the output. You have to place all the box one by one. That is the partitioning blocks. So if you have any doubt, you can ask or we can meet tomorrow.
Sir, can you explain every jargons that we use, like netlist and all?
Can you repeat your question, Jamie?
सर हम जो वर्ड्स यूज करते हैं टेक्निकल वर्ड्स लाइक
हाँ
गेट लेवल नेक्स्ट लिस्ट और बहुत सारे
हाँ
जो शायद मुझे भी नहीं
हाँ,
पता, क्या आप
अच्छा
एक
अच्छा,
बार सब कह सकते हो, एक्सप्लेन कर सकते हो कि क्या
क्या
कहाँ
बात
पे
है.
आता
Yes. Let me show me that slide. Okay, after this slide there are so many slides. I'm not just I am quickly यहाँ पे 1.8. This is the chapter number 1. यहाँ पे सब आएगा. What are the terminologies available in the VLSI physical design? So once this point will come, we'll definitely discuss. At present we are here. अभी ये steps हम सीख रहे हैं कि कौन कौन से steps है. That all terminology, graph theory will come here in this point. Netlist, what is netlist? How to write down the netlist, like that. What is graph? Everything will come.
Uh,
Huh?
Sir, in software term, we can say that netlist is the data type of wire.
Data type of what?
Wire.
Wire. Oh, wire is not only the wire. It not gives only the A connection with B. It gives input of A as well as input of B, and which type of A is there? This OR gate, NOR gate, NAND gate, like that. Just wire is not enough. We need which type of gate. So that information is also there.
Okay. That means a wire also vary with respect to gate.
If gate is very far away, connection require long wire. If it is shorter, nearer to each other, it requires shorter wire.
Okay, sir.
There is a link A to B, but you have to define proper way in the netlist. So we take the example. If I am giving some logic diagram, we'll understand manually how we can write the netlist. Any other question?
Hello, sir.
Yes.
Am I audible?
Yes, Parthiv, we are audible.
Yes, sir. So on Friday, I am facing a network issue on Friday, and regarding to this, my lab session, I could not understand the lab session in a clear
Mm-hmm.
manner. So, sir, is there any lab recording available to you so that you can forward me and
Okay, lab recording for each and every course and each and every lecture is available. Definitely, I will forward to you.
yes, and regarding to that, sir, I have forwarded one email, mail to you, sir.
Yes, okay, I will forward the lab recording, no problem.
Okay, sir. Thank you very much. And also, sir, if there is any group of WhatsApp group is available,
WhatsApp group
class.
is
Yes.
available with your classmates. So better Jamin can answer. You can answer it? You can add the Parthiv also.
Sir, I mentioned my number in the chat box.
Oh, let me check.
Okay, sir.
Group admin can add because I am not in WhatsApp. This is Parthiv number. So communication is possible.
Yes, sir. That's why.
Okay. So Jamin, if you are admin, you can add or someone else can add.
Thank you very much, sir.
Sir,
Oh,
Shivang is admin. He will definitely do.
okay. So thank you for joining. We'll continue more example tomorrow. Okay.
Thank you, sir.
Thank you for joining.
Thank you, sir.
Thank you, sir.